Okay, good afternoon, good morning, good evening, whatever time you're in, time zone you're in, different parts of the world. I want to welcome you all. This is Krishna Vedula from IUCEE, Indo-Universal Collaboration for Engineering Education. This is again one of our regular webinar series, collaboration with the International Federation for Engineering Education Societies and the Global Engineering Deans Council. So thank you all for joining us from different parts of the world. So today we have a very unique presentation. This is from Uganda. Okay, so engineering pedagogy and the interplay between work and learning life in Sub-Saharan Africa, a case study in Uganda. Okay, so Vincent Olema is our speaker, and you can see him just for a little bit. He'll turn off his video. Just in case the Wi-Fi becomes an issue. Let me take a couple of minutes to talk about Vincent. Vincent has extensive experience in the telecommunications sector. He has worked with numerous telecommunication companies in Uganda, including Siemens Uganda. He currently serves as Head of Information and Communications Technology, Research and Development for East African Entrepreneurship Association. He is the founder of a non-profit named Namunde Labs that promotes technology, engineering, and math in Ugandan schools, and the founder of Logic Technology, which is an ICT company which provides ICT services. Vincent holds a bachelor's degree in telecommunication engineering and a master's degree in vocational pedagogy. Wow, that's an interesting field. Great. He's a member of many professional associations, IEEE, Institute of Engineering Technology, Uganda Institute of Professional Engineers, Engineers Without Borders, Rotary Clubs, and IEEE Smart Village. Olema is the founding chair and past chair of IEEE Uganda section, IEEE Membership Development Officer for the Uganda section. His research interest is in e-learning, Lego education, mobile learning, vocational guidance, vocational education, workplace learning technology. He published several articles in these areas. So welcome, Vincent. Fantastic. We're really eager to hear what you have to say. And thank you for taking the time to come here and present us. Okay, so I'm going to turn off my video, and you can say just hello and turn off your video too if you want. Okay.
Yes. Thank you very much, Professor Vedula, for the opportunities and also introduction. And then also, I would also like to thank Professor Hans and alongside Aliki for the opportunity given to me to do this presentation. As Professor Vedula said, I'm from Uganda. I live in Kampala, and you are all welcome. And good evening, good morning, and wherever you are, please. So, and these are my thoughts and also my presentation in the area of in the area of engineering pedagogy or engineering education. So for now, I would like to put my webcam off because of the internet, it might bring some problems. So let me just put it off now for now. Thank you. So just remain here at the moment. Here in Uganda, I do quite a lot of working with my organization, non-governmental organization, to promote STEM, science, technology, engineering, mathematics. And then at the same time, I'm also doing a volunteering teaching job with St. Benedict Technical School. That's just the second town after Kampala on your way to Interplay International Airport. So here there is students who are trying to build Lego, and then also here we're trying to do some work for building face for COVID-19, and also open a door, because here this is a door. We developed some equipment that will be able to help us. Instead of touching the door handle, we use that device to open it. And then down here is my class with the students, with pupils in primary 1 up to P7. Normally do this. They like the lab because it's the practical. Their laptop, their there are mobile phones, there are also tablets in here which are also stocked with the installed with the software, learning softwares. And then here it says this for young students, they are also designing, they designed this system using the logo products. Now, as I mentioned, they already talked about me or introduced me, so I am not involved talking about myself. So I'll just go direct to the topic. So my outline here is just definitions because I've used so many words which you may need to know, especially engineering pedagogy. Until a few years, that's when I learned about it. And even still in this part of the word pedagogy, so many people still ask about it. And then also there's this engineering education and also interplay, the work, learning life. Then also some parts, some people may not know more about Sub-Saharan Africa and also Uganda. Uganda, of course, happens to be one of the countries located inside Sub-Saharan Africa. Then, of course, we have why we are here. We're here for engineering pedagogy. We want to learn about what is happening in this part of the world. Then the area of focus, what do we need to focus on to change things around? Then the ideal skill sets for engineering pedagogues. Visible challenges. These are challenges that we see every day. If we can solve those challenges, we can sort our problems here. Then my thoughts about the engineering pedagogy. The recommendations that I will also provide, the change we want, how do we want it to be, then the conclusion, and then I'll later on also request a session to give us questions people so that you can go to answer. So the first question is the first definition is engineering. So sorry. Engineering. What is engineering? Because some people can talk. I'm an engineer or something like that. So it's just a branch of science and technology is concerned with designing, building, and use of engines, machines, and structures. The moment you go into this field, there's nothing to sit down. You need to open yourself to the world by playing with the facts of around science, technology, and also in design. It's about playing with the objects really. Engineering, I always say that engineering plays a key role in development. In the area of technological capabilities, that's why you see the first world, they are good in this area. So the developing worlds must be able to go into this direction. Then the industrial activities and then economic growth, because once the economy can only grow when we have sound engineering system in any country or in the area. But if you don't have, then it may not go that far. Generally, what is engineering education? It's just activity of teaching knowledge and principles to the professional practice of engineering. Or it can be formally engineering training received in an established institution in which institutions and principles are disseminated or transmitted in the classroom, while the practical classes are supervised and specific and controlled to impact skills. And this is mentioned by Akinsanya, which was in 2013. For him, he says that the real learning takes place in the classroom. That's the teacher or the instructor or the lecturer. And then the practical part takes only part only outside, or when it's in a place where you can be able to, or in a factory, it can be in a garage or something like that. I also have also assumption that education is sometimes perceived as a sector which is resistant to change, while at the same time it faces a crisis of productivity and efficiency. You see, even here in Uganda, across the Sub-Saharan Africa. In an institution, you want to bring a change, I'm telling you, you can have that stiff resistance from the leadership of the institution and also the society. So always people resist change in this area. And yet people keep on lamenting that we have a poor education system. But because somebody comes with an idea and it's not implemented, and that's where the challenge now normally comes in. So people are so rigid in this area. Now, here comes now the pedagogy. Engineering pedagogy is a branch of education that impart knowledge and principles to the professional practice of engineering. I always involve myself in engineering pedagogy because it gives me an opportunity for me to do my things as the way I think, and practically I try everything, and that's where the thing. Pedagogy focuses on the practicality of the course, not in the theoretical. So the Sub-Saharan Africa, including Uganda is inclusive, must be able to take this leap. Because for me, this is where we are lacking in this area, because we are always theoretical. The lessons only people only attend in class, but no practical bit is taught outside. Always, engineering pedagogy is also the acquisition of knowledge or skills through study, experience, and being taught. Now, the interplay. Interplay is something that when you have 2 or 3 things which affect each other, the one affects the other side. And that is like engineering pedagogy also affects the working life, the learning life, and that's where it is. You cannot throw it away. It must be within for it to work, to survive, to work well, to achieve the objectives of engineering education or pedagogy. So it must be that interplay for it to work. Work, all we know it, everybody say that after job, you need to get work. That's the thing. What is it? It's activity involving mental, physical effort done in order to achieve a purpose or result, because the work must give you results. That's it. So if you don't have competent people, skillful labor, then you may not get that work. It may not be performed as required, and that's why we will continue to be in that. Especially the sub-Saharan countries will always remain one of the poorest areas of this planet. Then we talk of learning life, the acquisition of knowledge or skills through study, experience, or being taught. You see, one time, just one example I want to give here is that in my village where I grew up, we don't have electricity. People use the kerosene lamp. So a young girl was playing inside the hut. The mother put a kerosene light in around 8 there. The girl went and touched the light, and then it burned, started crying. So the mother came and picked, then consoled the baby, and then after that, then after 2 days, they put the same lamp near where it was, and then they pushed the child to this lamp. The child started crying before even touching it, because she had learned something. So it is always we learn, every day we learn. So we continue, if we want to develop this region, we must be continuously learning, and even as individual or as a society. Now, we also have what we call long life learning, which is part of the learning life, which is, I always draw this attention to my peers and also my students, that learning will never stop. And if you stop learning, or you say, no, I don't want to get any news by attending conferences, doing presentations, just such as this is an experience for me, I'm learning, and the learning must always continue until, God forbid, you are dead. So the other definition I wanted to also mention is the Sub-Saharan Africa. Sub-Saharan, this word is so common because not many people know about Africa. Geographically and ethnocultural, the area of the continent of Africa that lies south of Sahara we have Sahara Desert, which is northern part of Africa. There's a Sahara Desert. So every country, the countries that are south of that desert are normally characterized as Sub-Saharan Africa. Apart from other countries like Algeria, Tunisia, Libya, Egypt, including Sudan. However, there are 48 countries, namely Uganda, Kenya, Rwanda, Burundi, Zambia, Nigeria, Ghana, South Sudan, the newest actually country that has joined us also, and then Egypt sometimes also is mentioned under Sub-Saharan Africa, and then also many others which have not mentioned here. Now, we have these two, because this down, when you look at my screen, my presentation screen, you will see some logos. The first logo, which I've also indicated here, is the IGIP, which is the International Society for Engineering Pedagogy. I remember about 1.5 months ago, we had a presentation specifically about the engineering pedagogy, about the IGP. And this organization actually is one of the things that these countries need, really, including Uganda, because it has a lot of things for the engineering fraternity, education fraternity, because they do training of educators, especially in the universities, primary, secondary, education, also people who are interested in that. I always wanted I joined the IGIP as a student, but I wanted to upgrade myself to be a full member because I joined it when I was at the graduate level for my master's, because I was looking around, and that's when I came across the word IGIP, and then I also came across the word IFEES, and also GEDS, that's the Global Engineering Dean Council, International Federation of Engineering Education Societies. I was really privileged to enroll and also sign the email, and the Professor Hans kept on sending me email immediately after some time. I did a publication of one of my projects in the lab that is working with the STEMs and a lab, a primary school here in Kampala. So it's good that we need to join these organizations. And then also I wanted to do the exams for International Society for Engineering Pedagogy. I've not received any feedback, but it's something that, although I got the feedback, but they told me that we don't have a center in Africa. So if I wanted the center, then I needed to, I think, in Europe or something like that. So these are the things that we need really for African continent, so that the educators can be able to upgrade themselves and also learn a lot from the developed world, where these things have worked. Engineering pedagogy has worked. Now, the International Federation of Engineering Education Society is a device in culture, because there are so many engineering fraternity who are there, and also affinity people who always want to be associated with the engineering education. They are always, you can become a member of this. I'm really proud to be a member, to receive the email, also do the presentation, which I'm doing now. Then we have the Global Engineering Dean Council, which started in 2006, and it's a world's largest network of engineering deans, executive leaders, and other stakeholders in engineering education. So I'm thinking that if our universities can be able to, the leadership and also the lecturers can be able to join this kind of associations, and then also participate in the conferences, the webinars, and such like this, and then they can be able to learn a lot there. Yes. Now, look at the engineering education, especially now. Let's now to the East African country. It started later after other disciplines such as the social sciences. So engineering education now came later because now there was need to bring output of labor because they needed skilled labor to in the production area to push forward because there was need for economic growth. So there was need to engineer products so that and provide services by this engineering fraternity, and that's when the engineering education came in so that they can be able to put it. And engineering education at post-secondary level was established to increase the local engineer practitioners. For example, when you look at it here, down here, for example, the formation of East African Community in 1967, shortly after independence, helped unify the education system across the countries in the region, especially that higher education institutions were not many. That is by these writers, Kumar, Ocheng, and Onyango in December 2004. Now, what happens here when someone wants to join the engineering fraternity or generally engineering education? Of course, after the levels, we have especially now, most regions here in Africa, mostly they have the nursery. For me, I didn't attend because I had challenges. I didn't attend. I only just joined this primary one. I didn't join the nursery. I will tell the reason why later. So you go to the primary. After primary, you will join primary, which is 7 years in Uganda. Some countries it is 8 years. Then you go for secondary school. Here in Uganda, it's 4. Some countries it's 5. Then you go for advanced. That's A level. Me myself, I didn't go to A level. I chose to go for technical school and to upgrade to. I wanted skill because I didn't want to go with the advanced levels. So I went for skill and then technical certificate, diploma, higher diploma, bachelor's, and then a master's in that direction. So basically, a bachelor's degree program here in the region range between 4 to 5 hours. 5 years, because 4 years in Uganda here, our neighbor Kenya, they are 5 years, because they are, for them the secondary, there's also some difference that now with ours. So it is 5 years for degree. Then in the first 2 years, there's now the core course units. There's the normal, the students are concentrated those core. Then the second 2 years are now the specialized discipline. Like for example, I did a Bachelor of Engineering in Telecommunication Engineering. So in the last 2 years is now the course units that are, which makes me to become a truly Bachelor of Engineering in Telecommunication Engineering. So typical common engineering course units could be like engineering drawing, drafting, because you have to, because when you conceive an idea, there must be some drawing. Then they must know the material science or the materials engineering, statistics, and the dynamics, strength of materials, basic circuits, thermodynamics, and perhaps some industrial engineering. Many others not mentioned here because there are so many. Because, like for example, in the first year, you might find many. Would be like you even have like 13 course units. So those are just some sample that I've just mentioned for this purpose of the presentation. Now the degrees awarded are Bachelor of Science, Bachelor of Engineering, which I got, or Bachelor of Technology. Now after once you join the university, every 2 years, every second semester, after every second semester, you go for what we call internship, which is normally 2 months to 3 months. It depends from university to university or institution to institution. But this is normally at the end of semester of every academic calendar. So these industrial placements are normally supervised. At the end of the industrial training, you are supposed to write a report, and it is evaluated and also added on one, as a mark to your final results for you to graduate. Now we also have the polytechnics and technical colleges. For me, that's what I observed. After my senior form, secondary form, I joined the polytechnic to do electronics, and then and normally it is 2 years. But also, if you choose, you can even start from certificate. Some certificates are 1 year, others are 2 years, so it depends. Mostly 1 year is only for a craft skill, but you can continue and even become what you want. Once you have your ambition, then you can do it. Now, towards the end of academic year, the students graduate, and then often they do what we call the open-ended design project or a special project. We normally call it a final year project, and that project is also marked and also the marks added. Now, if after graduating and with undergraduate, you can the student can either go forward for master's degree or can just join the field or go to the work as we define there, just to go and look for a job and get it. Now, if you fail to get a job, then that's where the challenge is. And that's where we have a problem, because so many writers have said that the Sub-Saharan university, they don't provide the students they graduate when they don't have the skills. And that's why we have this presentation. Now, engineering education Sub-Saharan Africa, the teaching style in most academic institutions in the region can be described as chalk and talk. People just come to the class, the lecturer comes to the class with a chalk, and then with a paper and a book, an old textbook. It's as opposed to problem-based learning. You see, that's the thing. And that's why my organization trying to find ways of doing that by setting up labs, so that, and also teaching practically. You bring problems, people must use the problem to solve problem, learn from that problem. Now, there's a study which was conducted by Inter-University Council for East Africa in 2014. In that report, and also combined by Gilbert Nyanga, also emphasized that Uganda, every year, about 64 of university graduates are not equipped with the job market, are not equipped with job market skills. So the skills are not there. So the student will not have an idea of even starting a business. They don't have, even you have to train the student all over again. There's one officer who told me that, Vincent, we have a problem in this country. Once you when you employ a student or a graduate from one of the universities, you have to literally take the student back to class, because you have to train everything. The student have not, apart from students who are coming from the technical colleges, these vocational schools, because they are more practical than to use the students who come from engineering universities. So Tanzania, only 61%. Burundi, 55%. Rwanda, 52%. Kenya, 51%. Now, overall from this study, it was deduced that overall the picture looks like, while there is indeed a quality problem in engineering, the bottleneck in the line is a quality problem. So that quality is the thing that we need to study. The question here is, why are we here? We're here to discuss about engineering pedagogy. Branch, as we mentioned, it is branch of education that impart knowledge and principles to the professional practice of engineering. It is the education science that helps to identify, analyze the current and future demands of society, and come up with good curriculum content. Select the learning aid methods which technology to employ, and suggest the learning environment where the learning should take place. Engineering pedagogy is the foundation for transforming the social demand for professional engineers. Friends, the current engineering education status in Sub-Saharan Africa requires real overhaul. I'm very sorry to sound harsh, but this is a reality. They say it is always to say bare things so that society can transform. The deficiency of skillful engineers has been attributed due to the following reasons: insufficient output from the training institution, poor quality of engineering education system, lack of practical experience among graduates, engineer educators' lack of subject matter knowledge, and other. The speaker presents why engineering education has not taken off well. In this presentation, we are going to outline challenges faced by engineering educators, possible solutions to the challenges identified, and the recommendations for a better engineering system. Now, why the goal? The goal of engineering pedagogy. I like it because it educates students to master a deeper working knowledge of technology. Fundamentals. Because when I as the Dr. received the phone call for presenting as a hotspot. So we have that chat. While my master's certification in pedagogy, I found out that I was always constant playing with the items, and that's when I learned, I had a good deeper learning. I got deeper working knowledge. So this is why I say, no, let me present this paper, this presentation, so that people can also learn from me. Now, educate engineers to lead in the creation, innovation, and operation of new products and systems. Educate the future researchers to understand the importance and the strategic value of their work. Educate future lecturers or educators, because the students, some of them must become lecturers in future, because, and also that's something that we need also to learn. The students, the engineering students must go after graduating to work, they have experience, and come back to classroom. And this is when they can learn, have that opportunity to learn these things. And then also some of them will become lecturers, future researchers, so that people, the work they are doing must be known, the challenges they must be faced, they are facing in their line of work must be published so that people read and the solutions can be got. And that's the thing, that's the reason why engineering pedagogy is very important. Now, there is now the area of focus. I put it red purposely because, sorry, it's red because it's purposely. One is the curriculum. Curriculum. People are blaming, the industry is blaming the academic, these are the institutions. And then the academia is blaming the industries that they are not employing our students, our graduates. So there's that problem, which is every time coming up and so on. So that problem, until we address the problem of curriculum, the laboratories and workplaces, the lecture room must be laboratories and workplaces. Only attending few presentations, and then also there must be a lot of hands-on. Teaching resources must be enhanced. That's the area. Then assessment must be fair. You see, the assessment here, you find the students, the lecturers, some of them, they are happy to see students fail. They don't understand why the students fail. See? And even the teacher want to go back to the teaching resources. The resources are inadequate. The teachers, all the lecturers, they don't have experience. Some of them, after graduating, they remain as lecturers because they have got first class. They don't have experience. So experience, what we call experiential learning, is very important, because when somebody goes out in the field, like me, I go to class, I bring wealth of experience. I teach experience, even though I don't have the apparatus to carry out the practicals. But what you tell the students, the learners will be able to understand what you're talking about. So what is important here is also the experience. Then the faculty competence. They must be exposed to opportunities to attend conference, to join this association, so that they can be able to enhance them. Another thing is design a model in which these resources are better employed to promote student learning. this area must, a model could be the organizations, the higher for the the education system or the higher education system for each country, or talk of Sub-Saharan African countries. The countries must be able to come up with a model for each country so that people can be able to get these resources and better employ them and promote the engineering students. Mutual, it must involve, when talk of the curriculum now, then it must be mutually supportive, disciplinary subjects integrating, like for example, personal, professional, and product, and system building skills. See, it must not be isolated. All this must, when the student leaves the campus, must be all-rounded, not to go again to be trained, because that's where the challenge is. Now, any introductory course that provides a framework for engineering pedagogy motivates students to study engineering. We need to, the course, the curriculum must not be too hard. If it is too hard, students run away. Provide a set of personal experiences which will allow early fundamentals to be more deeply understood. Like, for example, when I go to the class, I tell my experience, the students learn from me. So the curriculum must also bring those personal experiences so that the students can be able to pick role models. Provide early exposure to system builders. And this is the thing, like what you see shortly, and also on my whatever we're working with the students are exposed early. And you see those are students who are, some now there's, I think 1, 2, 3 of them, they have graduated, but the rest they are in 3rd year and 4th year. But they already now have experience. They are doing their own things, and which makes me happy. Now teach some early and essential skills like teamwork. There's no isolation for engineering pretend to work. Engineering pedagogy to work. There must be emphasis of team spirit or teamwork. Nobody should be out there. For example, here, this is a robotic. One of my students trying to design kind of a drone using a local made and which is still under whatever. So, and this student is just in 2nd year. He's just in 2nd year doing a Bachelor of Electrical Engineering. Now, like this is in primary 7. This young boy is with a 3D printing. He was able to design a face shield to combat COVID-19, and we donated some of them to some vulnerable people, the elders. We donated some of them. Now here, this is I use the lab for Chabuk University. They have a lab where they have the Lego, and we normally go and use the lab because I was a student there, and also the class coordinator, and also passionate about this. And I've been also teaching this Lego for some for master students in this university. And then also this must be involved. All these things must be involved practically in the curriculum. Now, integrating learning experiences must be integrated. Learning experiences. In this learning subject, it's possible to construct learning experiences which integrate both technical learning and learning of engineering syllabus skills like problem solving, system thinking, experimentation, and so on. Like this, we're able to, with these students, we're able to design a complex system for breweries, for bottling. Then it is also important for students to see their role models, bring people to talk, people who are in the industries to come. And so these are things that we need to, people must move away from the old textbooks to the new model. I can even testify to you, I'm telling you, in some libraries in one of the universities, find it is in old textbooks, you cannot get, sometimes even to get new technologies which are now currently trending, you will not get them. So it's very important that we need to the institutions must take up. Involved with issues such as ethics, communication, enterprise, that's the entrepreneurs, societal problem. They must be able to, the SDGs must be emphasized. Then labs and workplaces, ensure that students practice in repeated design building experiences. Develop workshops that support hands-on learning of product system building, disciplinary knowledge discovery, social learning. Now, design with the experience. This young girl, she's called Elizabeth, we're designing a hand washing, this thing where you step and use it brings you water, hand washing equipment. So we involve them and how to make, and also use this to cut the metals, something like that. So she's doing telecommunication engineering. She's actually in her third year. So we involve them in this project, and so that they can be able to learn, because they call lockdown so that they can be able to learn. Because here the social distance, people are putting masks, and it is very nice for them. Now, provide authentic activities onto which more abstract learning can be mapped. Provide the natural context in which to teach engineering syllabus, skills, teamwork, communication, designing, and implementation. Reinforce by application previously learned abstract knowledge to be deepened comprehension. Actually, this is the thing we designed. We improved it well. Reinforce disciplinary knowledge discovery. Expose the students to come up with something using local materials. They are inexpensive materials that you can use, so that the students can learn. They can do creativity comes here, communication, because after doing that, they have to write a report and do presentation in front of the class. So presentation skills, communication, writing skills, creativity, they can all come all at one pack. It's something that the university must look at. System building, then also community building. So these are also topics that we design. This is one of because we delivered some of those door openers to some organizations here in Uganda, and this is the type of photo we took. And then also we also learned from them, because they gave us experiences. These organizations, they gave us what we can do, how we can be able to achieve our dreams, something like that. So it was nice for the students to learn from the industry. Now, teaching resources provide authentic experience supporting deep and conceptual learning of technical knowledge, as well as personal, interpersonal, product, system building skills, employ teaching learning methods based on active and experiential learning. Active and experiential learning or teaching. As I said, it comes from the word experience, using your experience to learn or teach. Active learning techniques stress students' active involvement in their own learning rather than simply passive listening. Students must not always be seated. And this is something which is here in Uganda and also across the region here. You see students, they sit from morning up to evening. They only go from evening for break, but the teacher reads, you have to write. So it is the writing, sitting. The students are not a challenge to think out of the box. Project-based and design building courses optimize active learning. Lecture-based courses can include one or several active learning strategies, such as modest point in the lecture cards, concept questions, and turn to your partner discussion. So these are things that students must be exposed. Laboratory workplaces, I think that's I've already mentioned that. Then assessment. As I mentioned, two assessments, in most cases, people, the lecturers, or some of them, not all of them, some want students to fail. They are happy when students fail, which is not supposed to be like that. There must be assessment of student learning that measures student knowledge and skill in personal, interpersonal, and skill building, as well as traditional disciplinary knowledge. Because also the engineering pedagogy must also know that there's also the local knowledge that the students must have. And the students said, every student is different. The lecturer must know, the assessment must take into account that each student is different. Student assessment must not be to fail students, it must be the one to promote, to give a student sense of happiness, sense of learning, that I'm learning, I'm achieving. Say thank you, evaluate progress against rigorous goals of the industry. The industry must be together with working with academia to come up with curricula and also assessment. Timely feedback to students so they can improve their learning. There's one student from one of the universities I cannot mention here. One of the students did student was 1 year was not able to interface with his lecturer or supervisor because he had submitted his research, but it took 1 year to get the feedback, which is something which demoralizes so much. So that's something that now is the assessment method matched to course learning objective? That question must be answered. Creating tools to assess personal, interpersonal, products, and the system building skills. Technical interpretation, written and graphic communication, team collaboration, product assessment, self-assessment, reflection on learning and achievement through journals, portfolios, and so on. I know my time is running. Now, the competence. Some of the, faculty, these are lecturers and so on, all the teachers, they must be constant to educate themselves, to learn, to carry on what called lifelong learning. Long life learning must be involved. Interpersonal, they must know how these things, be able to report or respond to the students' inquiry and answer questions quickly. Active and experiential teaching, and they must go to the field before they are not this thing of after graduating the person remains as a lecturer because he has got a first class. That's they don't bring experience to the classroom. So there must be that whatever the universities or the institutions in this part of the world must be able to understand that for you to be a lecturer, one has to get experience, industry experience, and also must work together in collaboration with the industry. Now, the idea skills now students must have include the following: technical knowledge and reasoning, knowledge of underlying sciences, skills in communication and persuasion, strong technical ability. The time is not there. Engineering reasoning, experimentals and knowledge discovery, system thinking. You must have that. But the industry always, as I mentioned to you, they have a problem. As Todd said, employer perception of weakness in today's engineering graduates is that one, technical arrogance, no understanding of manufacturing process, lack of design capability or creativity, lack of appreciation for considering alternatives. All that they want is to be analysts. They can't do a narrow view of engineering and related discipline, no understanding of quality process, weak communication skills, little skill or experience in working in teams. Visible challenges, academic institutions. They still follow the sensory old tradition and slow to change. The example that I wanted to experience, I wanted to bring from my institution. I wanted to my college to start what called innovation club. It took close to 7 months to get a yes, because that's the challenge we have. People don't want change. Forget governance process. Often talks propose changes to death. Education tradition in general is still stuck to teacher-centered, not learner-centered. The learning must be learner-centered. Strong culture focus on individual, not in the industry, not the institution. It's just individual. Especially the achievement inhibits what we call collaborations, especially across discipline boundaries. So also, as I mentioned too, there's textbook problem. Either they are expensive or outdated. There's a gap between the skills of graduate students and those needed in engineering. and also find this defect the quality of lecturers teaching in institutional lecture, poor attendance. No, the lecturers, they don't attend these lectures. They are always, they don't attend them. So you find that they have that challenge also. They must be attending this unstable political situation. That's why I mentioned earlier, I wanted my experience. I did join the nursery because at that time there was a political instability in Uganda. So I only, by the time I started school, I was a bit bigger. So they took me directly to P1. So those are the challenges that also affect our countries, some of the countries within the region. Unstable engineering roadmap, limited exposure to industrial practice. As you all said, 2011 said little or no coordination between research institutions and production enterprises. So there's the decline of infrastructure, fiscal infrastructure, adequate state funding, and under-equipped libraries, sciences, laboratories, reduced research and publication output, reduction in real value of wages, poor curriculum regime. My thoughts are now build advanced research infrastructure and communities in different areas, conduct detailed demand side study for engineering graduates demand and their employment skills. Course must be, before any course is brought into faculty, there must be, is there a demand? What are the employable chances of employment of the graduates? So that must be taken care of. Improve faculty motivation. Salary must be good. Working environment must be good. Remuneration, research grants must be there. Travel grants must be there. Scholarships must be provided. Rather than focus on skills in maths and science, we need to convey the excitement and impact of engineering. And that's what we normally do with the students, bring them and they play with the equipment, something like that. Employee, embedding entrepreneurship in the curriculum learning in higher education. Students and graduates must be able to be excited to get a job. No, not to get a job, but to create jobs so that they are self-employed. That's where the challenge we have. Just now the change we want is they understand the need and commitment of societies and the countries that we live. The leaders from the top must be emphasize this engineering pedagogy, the importance. That must go deep down. Early adopters must be brought in, especially bring the student, the STEM, just like the way we're trying to do here. From nursery, the kids must be, the pupils must be involved with the STEM, playing with the things that can inspire them to become, follow the profession of engineering or sciences. Quick success must be celebrated. Adequate resources must be available. Faculty learning must be constant learning. Presentation, send them for courses. Faculty recognition. Some people that achieve something must be recognized. Just like this, whatever. And active project-based learning. The students must be close interaction with the industry. Broad use of information technology. Because this school here, every week a student, people must come to this lab. Faculty devote to developing emerging professionals as mentors, not and mentees. Here, the lecturers, there's a problem. There are always problems. So the lecturer must become a mentor. The student must become a mentor. That relationship must be a makeup. If learning is to take place, there must be the whatever. Now, there is this other professional bodies that they must enjoy, the students must come to board, like IEEE, got its professional engineers, there is the FS, IGP, I say, but also the course, the universities must be able to, the institution must be accredited. And most of the universities are not accredited, most of them with the ABET. With those autobus, they are not ready. Blended learning must be now, because this is the reality. Absolute core hybrid learning or mixed mode learning, blended learning takes place. I'm doing some survey, kind of like to write a paper on e-learning. The students who are now at home, the university engineering students, are they learning using the modern ICT tools at home while they're at home? So that's another thing which is running. I might publish one a day. So e-learning must be part of the whatever. Conclusion, engineering is one of the areas the most attention, especially it deserves a key role of providing high-skilled personnel for technical industrial development. The acceleration of the education overhaul, however, has a number of visible challenges early identified. So this must be a teamwork, a collaboration. If it is not like that, then it will not work. These challenges need to be addressed jointly by sub-Saharan governments, education institutions, research, representative industries, and private sector. They teach more about real-world engineering design operations, including quality management, provide training critical creative thinking skills, produce graduates who are covered with engineering ethics and connection between technology and society. The students' education and training, especially STEMs, are necessary tools for the continent to unlock its potential. These organizations should come on board visibly seen to support engineering education and pedagogy in the region. My final and only final conclusion is that COVID-19 is an opportunity to rethink and organize in Sub-Saharan STEM, STIT, this is science, technology, and information, engineering education, research and development must be key. And thank you very much. And
thank you, Vincent.
Yes.
That was an extremely thoughtful analysis of the situation in your area, region of Africa, and you have provided some really interesting, very nice solutions. And actually, you pointed out things that actually everybody around the world are struggling with similar issues. So it's not a surprise, but I think it's good that we can focus on that you're able to focus on sub-Saharan region. So we still have just a few minutes left, and I want to give Hans time to make a few comments. Let me just check what the one or two questions that might be there. We got Martin Hoberg is asking, made several comments and questions. So maybe I should just let him give him a chance to get his work in there and get his words in there. Are the study programs accredited? Just the higher education or just the higher education institutions? Okay, could you be more specific about the skills missing among graduates? He's got a whole range of questions. Maybe I should just let him see the email ID at the bottom of your Vincent Olema. How is the email ID there? Can you put up?
It's Vincent Vincent.olema.o@iee.org.
Okay, vincent.olema.o@iee.org. Okay, so
yes. So I think that all questions can be forwarded to me, and then I can answer them.
Yeah. Because he's got about 4 or 5 different questions. It might take a while to go through those. But anyway, I'll let Hans Hoyer say a few words at this time. And
thank you very much, Krishna. Can you hear you?
Sure.
Professor Vincent Olema, I want to let you know from my perspective, this is one of the most relevant, inspiring presentations that I have heard in our global community, and Krishna Vedula and I work very, very closely. The relevance of what you've said, it's quite impressive. And one of the with so many things you've said, for example, one comment you indicated, give students a sense of happiness. That's beautiful from my particular perspective. And what I really want to do, and I work closely with my friend Krishna Vedula, to share your presentation really globally, because your insights, as Krishna had said, are relevant not only in Africa, but in many parts of the world that we daily per se. Just a couple of things. Again, I could speak in real details. We are planning our global conference this year in Madrid, Spain. I'd like to see some student engagement because that's an important piece. We work very closely with dear friends in different African countries. We help form the African Global Engineering Deans Council, and some absolutely top professionals there. I think we'll be really inspired to meet you, to a dear friend and brother and colleague leader, Funso Falade of the African Engineering Education Association in Nigeria is someone I will introduce you to. I just want to, I'm planting some.
I know him. He's my friend.
Oh,
that's wonderful. He's a close brother, and I could mention many names. I will personally work with our team to facilitate greater connections and get you involved. Next year, I'm working already very closely with the Dean in South Africa to have our global conference. And we're bringing together our organizations together with Funso Falava's organizations there next year. So I'm thinking ahead. I think we can do some exciting, relevant work that can have a meaningful impact on Africa that other people outside of Africa can learn from you, but you can learn from them. And that's very much at the heart of what we do. Just a final comment. I'm very privileged to work with a close colleague, Tagwa Musa from Sudan, coming together on the latest version of our book, Rising to the Top, focusing on African women engineering leaders of all generations and all that. I just want you to be aware of that. But again, I could go on. I was really genuinely inspired by your insight, your sensitivity, and the deep relevance of your comments that are applicable to Africa and the world. Thank you, Vincent, and peace be with you. Thank you, Krishna. Go ahead, Krishna.
Thank you, Vincent. Thank you so much. And as I said, the email ID is there if anybody wants to communicate with him. And with that, we will close. And by the way, Vincent is looking to relocate, to get a PhD program in some good institution around the world, right?
Yes, I'm looking for one. And the professor linked me with I think with the University of, but the feedback is not it has not come, but I'm looking forward to any university that will be able to help me out so that I can go ahead.
It's your level of scholarship and thinking and depth of understanding. I'm sure that somebody will definitely take you on and help you sharpen your skills and become a world leader in engineering education in the future. So thank you for being with us, and take care, everybody. Have a good day, have a good evening, good morning, wherever you are. Okay, thank you.
Thank you very much. Yes.
Bye-bye. Thank you. Bye-bye. Peace be with you.
Bye-bye.
Stay healthy.
Yeah, thank you.